Hi and welcome to this episode 26 of playing around with a little mini lathe. In the last episode I'd pretty much finished wiring up the cab. Now like everybody else, I grew up going to the beach and listening to a bit of Bob Marley, but it turns out that our number one fan Nico is not like everybody else.
Hey, cool. New episode of RTFM. Let's watch it.
In the last video you might have seen me switching over the jumpers while the board was actually powered up. I've since been told that's an absolute no-go. Not a good idea. Don't do that. Turn the board off first. You know how I've been struggling to get these three switches to drive the enable and forward reverse relays of the VFD. Yeah, I thought I needed like a pull down resistor or something. Wow, turns out I really don't know anything about this. I put a request on the Linux CNC forum, and PCW from Mesa took one look at this wiring diagram and said, you got the polarity reversed. Here we are in the Mesa's manual and it's pretty clear. Here's the first switch. Pin 13 should be the negative polarity and pin 14 should be the positive. I didn't realize that electronic switches are not like physical switches and they have a polarity, so I guess it helps if you actually bother to RTFM, so I'll switch those around and relabel those wires. 13 becomes 14 and vice versa. Switch 15 and 16 and switch 17 and 18. So hands up, which of you guys thought it was going to take much longer to scrape the machine than to do all this CNC work? Come on, you in the back, blue shirt, put your hand up. I know you thought it. Well, wiring takes ages. Guess people who do this for a living are probably way faster than me, but for me it takes ages. There's a YouTube channel by a guy called Tay, which you really should check out. You know, he got the channel name The Machine Shop. Who would have thought that that would still be available? Anyway, he's bought this beautiful old brick machine shop with a lay shaft up on the ceiling and a whole bunch of really old machines. Moved everything out, cleaning it out, modernizing it. Anyway, his YouTube stuff's great. I really like his editing and just really interesting guy. Check it out. Now let's start Linux CNC and see if that VFD is now controllable. Going into the HAL show. These are our outputs. So output 0 is my enable pin. So the first thing we'll do is turn the VFD on. Oh, whoop, the command is I need to set pin, set P. And then we'll set that to true. Next off we'll try the forward pin. Alright, now if I set it to false, it stops. Now we'll try the reverse pin. Something's knocking in there. And it also only makes that knocking sound in reverse, not in forward. So if I set 0 to false, it should shut down the encoder. Okay, perfect. That now works. Thanks a lot, PCW. That was great. Since I'm swapping over to the more powerful Kelling motors, I need to remove this wiring housing that I added for the X-axis motor and transfer that across. This is just a Hammond zinc casting, sort of thing you'd make a foot switch for a guitar or something in. And all I did was drill and tap a couple of holes into the housing of the stepper. Seems to have worked fine. I'll use the existing holes to pick up where I need to drill. I'm not sure why Kelling left a hole in this back cover where crud can get into the bearing, but I'll put some sort of a sticker over it. Couldn't find anything small enough, but I've got these old Aeroshell turbine oil 390 stickers. I think I'll just put the shell over it. That looks kind of cool. Right, time to start installing the cross slide. First up, I need to take this off. That's the nut. Get a bit of oil on that. Now we have the standoff. This motor mount plate needs to go on before I can mount it up, otherwise I can't get the motor past the back there. Now feeding the X-axis cable through its conduit. There we go. The green wire was from I guess a home switch I used to have on here. Maybe I'll put another one on, but not at the moment. These cables don't need to be that long, so I'll shorten them up a little. So we need to start PNC configuration. Here we go. So we'll start off with 50 of acceleration and 500 . Enable it.
Look, it's moving.
The direction is reversed. Let's increase the speed to 1000. I seem to remember back with the old motor and my old setup with bad gibs and all the other stuff, I think this axis was limited to about 600 millimeters per minute. Okay, so 1000's too high. Okay, let's try 800. Okay, so that appears to work. I'll need to check it with a dial test indicator. Let's try increasing it up to 900. See what happens there. So that's with the gibs very tight. I'll just move it up to 950 and see what happens there. Sounds awful. Well, it sounds awful, but it does still seem to be working. Let's take it up to... And at 975 it seems to work. So the recommendation is to drop it down by 10%. So that would take it up to about, let's call it 880. Next I'll set up the acceleration and then I'll put a clock on it. There might well be so little mass that the max acceleration is close to instantaneous. This PNC configuration tool for this is truly excellent. Very quick and easy way of setting it. Now let's see whether this actually returns to the same spot every time. Yeah, I'm going to call that repeatable. It seems to be returning to 12 each time. I'd say realistically this reduction is probably not necessary. These are such strong motors that if I were to direct drive the axes, I'd probably get much higher rapid speeds out of this. Basically the main reason I used this was I used to have much weaker motors and I wanted the motor folded down underneath this standoff just to make the whole system more compact. What I probably could do was If I replace both of these with a pair of 1-to-1 gears, I'd probably increase the rapid speeds, as would fitting a ball screw, cutting down the friction of the screw as well. But 800 millimeters per minute is kind of plenty when you've only got 95 millimeters of travel. So I'm happy with that. I'll leave that as it is and move on to the Z-axis. Now that we've got the Z-axis installed as well, let's tune it. Starting off at 500 millimeters per minute and an acceleration of 50, once again as before. So just set it there in about the middle of the travel. That axis already faster than the X-axis at 1000. Let's see if it'll go any further. Try that, 2000. Let's just increase that acceleration a bit. Okay, let's increase the movement distance just to make sure it's not binding somewhere else. Man, does it go faster than this? This is insane. Okay, that answers that question. Well, it's a bit like Christmas today. The USB hub that I ordered just arrived. I worked out that I'm going to need three USB ports up in the controller section of the lathe. One for the touchscreen, one for the keyboard, and I want one like an external connection so that I can just plug in a USB stick whenever I transfer a file. So those are those three. It's actually got four, but I'll just use the three. So the next challenge is going to be getting this cable down through into the lathe. And also, and kind of off topic, but hey, on a show like this, I don't think anyone's going to complain about looking at cool tools. WNT drill chuck for the Mahu. Beautiful piece of equipment. These things normally cost about €250 or so. Seems in perfect condition, and I got it for I think $70 with postage from a guy, which is really cool. So I've been looking for a decent drill chuck. Now I got one. Okay, well that's what I was afraid of. I thought I might be getting the cart ahead of the horse here by installing the 2 motor cables already. So it looks like I'll have to disconnect the 2 motors, pull their cables back through, which will allow the head of the USB to go through, and then I can feed those 2 cables back. Oh well. Plus I guess I also need to run 1 extra cable for the e-stop, because I haven't done that either. 1 step back to make another step forward. I'm always kind of surprised when I do something like this, where I have to back up and repeat a step that I've already finished, that there's a lot of sort of mental inertia. You really don't want to do this, and you sort of look at other half-assed ways to do the job. But once you bite the bullet and just undo it and back up, it only takes 20 minutes often, and you're back pretty much where you were. So guys, do you also have like a box of wire, miscellaneous? Might be useful for projects, which looks like mine. Unfortunately, it's kind of outgrown this little box a little, but oh well. I think I'll butcher a Ethernet cable, because that'll give me 8 conductors, 5 for a jog wheel, and still have some left over for e-stop. I don't feel too bad about this cable being chopped up. It's ancient. It's only a Cat 5. It's only a 100 megahertz cable, so it's not like you'd want to use it on any modern project. Right, so back in the box, or on the box, and out of sight, sort of. That's fine. What we're going to do next is set up a test for lost steps. Well, it does seem to be repeating back within about 1/4 to 1/2 of a 100th of a millimeter. I'll stop that. Let's set up next to check the backlash in the system. See if we then get lost steps after it's got backlash compensation set up. Okay, so it looks like it has about 1800s more backlash than currently set. I go into the ini file and set that backlash to 18 more than that, which is 0.22, 0.23. May still need to go down a little bit less, maybe. That's probably as good as I'm going to get it. Well, I still got a little bit more work to do on adjusting the backlash of the cross slide, but I'm kind of out of time for this week. So once again, thanks a lot for watching, and look forward to seeing you again next week.